Hello everyone, I'm Stefania and today we are exploring Spring Security defaults, where Spring Security fits in your application, and we'll build our first Spring Security project together. Security is classified as non-functional requirement. It focuses on how a system performs under different conditions rather than defining specific functions or features. Non-functional requirements fall under the ELITIS list: availability, maintainability, security, operability. Examples of non-functional security requirements include the application must comply with GDPR, or sensitive data must be protected with strong security measures. The system must resist common attack vectors. Now, some non-functional requirements can be expressed functionally, like two-factor authentication is required for all the accounts and inactive users must be logged out after 10 minutes. These are features that users directly interact with, and they can be implemented using Spring Security. But not all non-functional requirements translate directly to user-facing features. For instance, the system must validate all inputs or data must be encrypted. That's not something the user can interact with them, but is crucial for him and the system integrity. So we define them as non-functional requirements. Spring Boot and Spring Security follow the design principle of convention over configuration. It means you get secure defaults out of the box, but you can override them. If we consider Spring Boot alone, a default example can be that it automatically loads properties from the application property file in the resource folder. But if you want a custom location, you'll need to configure that explicitly, either via the command line or another file. Now let's talk about what Spring Security gives you by default. For the authentication and authorization parts, all requests require authentication, otherwise they'll give you 401 errors. All endpoints require then authentication by default, except for login, logout error. A form-based login page is provided. A default user account is generating a startup and stored in memory. CSRF protection is enabled, and it uses Bcrypt as the default password encoding algorithm. The default user is also assigned the role user authority, and all the roles are prefixed with the role underscore string. Spring Security applies a default set of filters, which are set by the HTTP security object inside the security filter chain bin configuration. If you want to see which filters are applied as default, you can pick up the first branch from the Git repo, 00 filter chain, and run the program. The code contains just a configuration file, which loads a security filter chain at startup. Then we'll print out the order filter list. Let's take a look on some of the filters. Security context holder filter will store and clear the security context for each request. Header writer filter will help protecting against clickjacking, MIME sniffing, and caching sensitive data. CSRF filter. All the state changing requests, nor the GET, are denied if they are not containing a valid CRF token. But Spring Security is also super flexible. You can customize all of this to fit your functional needs. You can add two-factor authentication or multi-factor authentication, role-based access control, have custom password hashing, and depending on your architecture, you can also go with JWT-based or session-based authentication, custom security filters, etc. In this and the following videos, we are going to explore all of this and more together. Security is always a trade-off between simplicity and cost on one side and effectiveness and complexity on the other side. Think of setting up Spring Security like you are protecting something super valuable like a Lamborghini. You wouldn't just leave it parked on the street overnight, right? Instead, you like put in a private garage, maybe add an alarm system, and even set up surveillance for extra peace of mind. Spring Security's defaults are quick and convenient, but for real protection, it's worth investing the time to build a custom, well-configured security setup. So, what's your app most valuable asset? User data, business data, data in storage, data in transit, data in use. No matter where it lives, protecting your data is absolutely critical. Only authorized users should be able to access, view, or modify this data. We want to prevent unauthorized access, data breaches, and misuse. So how do we make this happen? First, we need to identify the user, and that's authentication. Our second step is to verify what the authenticated user is allowed to do, and that's authorization. Can they read, write, delete? Just logging isn't enough. Access must be controlled. Another Spring Security pillar is data integrity. We need to ensure that data hasn't been tampered with. We can do that by using hashing and encryption. The application must be defended against cross-site request forgery, cross-site scripting, and other common attacks. Another pillar is to log all the authentication events, capture both failed and successful login attempts. This helps with compliance and is vital for post-incident analysis. Repeated login attempts can compromise authentication. It's important to consider rate limiting or lockout implementation too. One of the best practices about security is having a zero trust mindset. We need to assume that any other part of the system could have already been breached. Even your internal systems should be treated with caution. Here's what it means in practice. Secure every endpoint and treat internal traffic as it were public. Validate every input and don't assume that your firewall will block everything and proxies will sanitize harmful headers. Now we're diving into the simplest code example using Spring Boot security. The GitHub repo is linked in the description, so feel free to follow along and experiment with me. I'll be using Kotlin with Maven, but you can absolutely use Java if you prefer. Let's start by creating the simplest Spring Boot security project, just to understand some of the default behavior it gives us out of the box. You can generate the project using IntelliJ Spring Initializer, and for now we just add the Spring Boot Starter Web dependency. This gives us everything we need to build RESTful web services. I will create a minimal REST controller with a single hello endpoint. We can run the application and hit this endpoint either from the browser or the terminal using the curl command. The -v flag stands for verbose. It shows detailed information about the HTTP request and the response, including headers. And we can see that our simple backend will return the string hello mama. To secure our endpoint, all we need to do is add the Spring Boot Starter security dependency to our project. Once we refresh Maven dependencies and restart the app, we can take a look at the console. You'll see that Spring Security has generated a default user with a random password in memory. Now, if we try to access the same hello endpoint like before with the curl command, we'll get a 401 unauthorized error. Why? Because Spring Security is now protecting our endpoint by default. And if we visit localhost 880 in the browser, we'll get redirected to a login page, automatically created by Spring Security. So what's the difference between 401 and 403 errors? 401 means unauthorized, the client is not authenticated. And 403 is forbidden, the client is authenticated, but it doesn't have the permission to access the resource. Spring Security uses HTTP Basic as one of its default authentication schemes. Other authentication schemes are bearer tokens, JWT, API keys, etc. With basic authentication, the username and password are sent in plain text, basic C4 encoded in the request headers, so it's not very secure for production environments. To make an authentication request, you can use the curl command -vu user password and endpoint. If we change the password, we'll see another 401 error, confirming that authentication failed. Instead of using the flag -u, we can build the header ourselves by base64 encoding our credentials manually. With the echo command, -n, user, password, pipe base64. And then we make the request like this. Let's underline that base64 encoding is just for data transport, not for security. It's not encryption nor hashing, so it's better avoid its use in production. In this video, we secured the basic endpoint, explored Spring Security default behavior, and took a look behind the scenes at how HTTP Basic Authentication Scheme works. If you found it helpful, give it a thumbs up, subscribe for more content like this, and feel free to drop any questions in the comment. I really appreciate your feedback. See you next one!